on understanding equivalent fractions. So understanding that some fractions mean the same thing. All right, so now we're going to be moving on to our lesson. So open up the packet that I have given you. It looks just like our book. It'll be on page 367, which should be the top page on your thing. And we are going to do lesson 17, session 1. All right. So we do have a learning target. So we can explain why a fraction AB is equivalent to a fraction n times A and n times B by using visual fraction models with attention to how the number and size of parts differ even though two fractions themselves are the same size. Use this principle to recognize and generate equivalent fractions. So again, we are going to rewrite that into a we can statement. I know I usually have you guys do this, but since you can't respond to me, we're just gonna do it this way. So we can determine equivalent fractions based on multiplying a fraction by a whole. And why, again, might sound a little complicated. As we get through this lesson, you guys will have a better understanding of how we can determine if a fraction is equivalent to another fraction because we will be multiplying it by a whole. So let's start by doing this warm-up. I'm going to have you guys pause the video and I just want you to try your best, okay? Think about what you know about numerators and denominators, and I want you guys to just try your best in identifying how you would write these as a fraction. So pause the video and write it just on the top of your paper, maybe next to where it says explore equivalent fractions. All right, so in this first one, what I see is there are 4 equal parts. I know that there are 4 equal parts because I see here. I see 1 equal part, I see 2 equal parts, I see 3 equal parts, and I see 4 equal parts. I know that according to my definition, that the denominator, the total number of equal parts, is going to go in the bottom, and that will be 4. Then I know by my definition in my dictionary that the number of parts that we are looking at or describing is going to be the numerator, and that's going to be the number that is shaded. I see here that numbers 1, 2, and 3 are shaded, so I know 3 out of the 4 are shaded, and the fraction that is being shown. My computer completely went blank, so I'm gonna have to ignore my big head for a second. Okay, there we go. So I see that 3 out of the 4 are shaded, so the fraction that is shown by the shaded part is 3/4. 3 out of the 4 are shaded. So after you kind of go through, after you heard my thinking about that, look at number 2 again, okay? What is the total number of pieces that you have? That's going to be the number in your denominator. The total number of pieces that I have is 8. So I know my denominator is going to be 8. Then I think about how many is shaded. I see 1, 2, 3, 4, 5. 5 out of the 8 are shaded. So that's what's going to give me my numerator of 5. This represents 5/8, and I'm always talking about the parts that are shaded. I know it can be kind of confusing, but what I want you guys to understand is when we're talking about identifying a fraction of a graphic like this, we're always talking about the shaded part, okay? So 3/8, while that does represent 3/8, I'm asking you to identify the part that is shaded. Okay, so make sure that you understand that we're always talking about the shaded part of the shape. Okay. So we're going to start by posing this question, kind of the question that we're going to be answering throughout this lesson. What is really going on when fractions are equivalent? So as this lesson goes on, we are going to be talking about what really goes on when fractions are equivalent, when fractions are the same. All right, look at number 1. Put your finger on where it says model it. I'm going to read, you're going to follow along. Model it. Complete the problems and models below. Number 1. Look at the area models below. A, write the fraction of each model that is shaded. So again, we're talking about shaded. So I'm going to blow it up here so you can see it a little bit better. I'm looking at my denominator. I always want to find my denominator first because it's talking about the equal parts. So my denominator here, I can see, I'm just going to count with my finger. Okay, so you shouldn't have to draw on yours, but for the sake of showing what I'm thinking, I'm going to show on mine. I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm counting carefully, and I know that my denominator is going to be 10 because I have 10 equal parts. 10 equal parts is my denominator. So now that I found the number of equal parts, I am going to go over the parts that are shaded. I have 1, 2, 3, 4, 5. 5 out of the 10 are shaded. And so my numerator is 5. Like you heard me say before, 5 out of the 10 are shaded. 5/10 are what's shaded in this picture. 5/10 is what is represented. Okay, now moving on to this next model on your paper. I first find my denominator. Right, my denominator is going to be the total number of equal parts. Total number of equal parts, this one's a little bit easy because I can easily see 1, 2. 2 equal parts. And how many of the 2 are shaded? Just 1, showing me that 1/2 is shaded. Now do not say 1/2s are shaded. The way that you read this number is 1/2, okay? When there's a 3 in the denominator, you read it as a third. 1/3, 1/4, 1/5, just like how you would say the date. Today is March, I don't know when you guys are actually going to see this, but March 23rd, March 24th actually. You would say 1/24. However you would read the date, that's how you would say the fraction. Except 1/2. 2 is half, and then 1 is 1 whole. Okay. So then it asks me, how are the models of the fractions the same? How are they different? Now, what I notice is if I'm picturing this as a pizza, I picture this as a pizza that has 10 slices, okay? If I eat 5 of them, one, I'm going to be too full, but also I am going to have eaten half the pizza. 5 out of the 10, that's half of them. If I were to have a pizza that's cut into 2 slices and I were to eat one of them, I'm eating 1/2. While these models show that they are 2 different fractions, they are equivalent because the same amount of pizza will have been eaten. Okay, so that's how these models of fractions are the same. Although that the numerator and denominator are different, it's talking about the same pieces. It's talking about the same parts of a whole. It's not talking about the same number of pieces because over here I would have eaten 5 pieces of pizza, where here I would have eaten only 1, but I would have eaten the same part of the whole. So I'm going to be writing that down. And after I write it down, please pause so that you can write it down as well. The models parts are just are different sizes. So the models have the same amount shaded of the whole, the equal parts are just different sizes. Pause it, write this down. Alright, so I'm moving on to number 2. Equivalent fractions name the same part of a whole. Shade the models to show fractions equivalent to 1/2. Then name the fractions. So I know I want to make equivalent fractions that are equivalent to 1/2, equal to 1/2. So in my model here, I see that there are 2 equal parts, one of them is shaded. In A, I need to figure out how many equal parts there are. Well, there's 1, 2, 3, 4. So I know my denominator is going to have 4. If I want it to be equivalent to 1/2, I know